Hey everyone, today I'll be going over problem 2000, a reverse prefix of a word. So as I always do, I'm just going to get the test case and explain what they want. The link is in the description, so you can just check it out. So we're given this test case, and we're given some word and a character. And basically we want to reverse the segment that ends in this character. So you can see here, if we chunk this out by the segment, so this is D, the segment ends in D here. We want to reverse that portion, so that'll be DCBA. And then we want to just add the rest of the characters, so EFD. If we look at the example here, this is actually the answer we want. So this is good, this logic works. You could do this a number of ways. I see people like finding the index of the character and reversing the substring, or reversing the substring that ends in that index, and then adding the rest of the word. You could do all that, and that's fine. I'm going to try to do this as interview friendly as possible, so just using like pure data structures. And I know a data structure that works really well for this, and it's a stack. And the reason why is because if you remember, a stack is last in, first out. So that means if you pop from the stack, it'll actually be in a reversed order. So what we're going to try to do here is we're going to go through this word as so long as we don't find this character. And the moment we find this character, we basically want to terminate, and that'll have the stack will have the segment. We pop from the stack, it'll be in a reversed order, so the segment will be reversed, and we'll just add the rest of the strings. So we're going to actually keep a flag here, and I'm going to call this found. And this will be because the reason why we need this is if we look up here, if the character does not exist in Word, we do nothing. So basically, if we never find that character, we just need to return a word. So what I'm going to do is I'm going to do a for loop, and this is going to be starting at I. Now for the condition, it's not only going to be I is less than word dot length, but we also want to be and not found, because we want to go through the word and also stop if it's been found. So as normal, we just increment it. So just a regular for loop, but we just add another condition. And then what you want to do is basically, no matter what, you want to append the character that's at this index. So we add that to the stack. And basically what you want to do is we want to set this flag to be whether this is the character or not. So basically found is just going to be equal to, found is just going to be equal to whether this word dot chara I is equal to ch, because that'll mean this will evaluate to true, and then found will be true. So yeah, another thing that we need to do is we actually do need this I outside of this loop, because we need to know where the segment ended, because we need to continue where it left off. So actually, rather than it being a for loop, we want it to be a while loop, and we're going to pull this variable to make it accessible to the rest of the code. And we're just going to go like this. So pull that out there, and then go like such. So that's good. And basically this will guarantee that I is going to be after the segment. So if we find the character, then I will be after the segment. So next thing is if we never found it, let's just return word, because we don't want to reverse it if we never found the character. And then the next thing we want to do is we want to reverse that segment. The segment is in stack currently. So basically how we do that is we're going to have a string builder, and this is going to be our result. And we want to go as so long as the stack is not empty. And we can use is empty or whatever. I just do this. So basically, as long as it's not empty, let's just pop from it. So let's append the popped character from stack. So that segment will be reversed. We know I is after the segment. So then from here, what we want to do is we just want to add the rest of the characters. So basically, what we want to do is while I is less than word.length, so continue through the rest, let's go ahead and just add the rest of them. So stack.append word.char. Let's see here. Okay, so, and not stack, but res. Now, so this will add the rest of them here. And let's also increment this while we're at it. Now, let's see here. Let's just return to string on the res. And this should actually get us where we want to be. So let's run this code really quick. Stack.append, and this is actually add, sorry. I got confused. And run this. And looks like this is where we want to be. Let's run some other test cases just to make sure. Make this Z. And let's just go ahead and submit this. And yeah, it looks like it's pretty good. 91 space, 70 runtime. So let's talk about time complexity here. Basically, it's just all going to be on. It's just going to be on space, on time. The reason being is because we're really just going through each character in Word and then filling up the stack. The worst case is we fill up the entire stack, so space will be on. We have to go through every character in the string, so realistically that is also on time as well. There's really no other funky logic here, so it's just on time, on space. So I hope this was helpful. It's a pretty interview-friendly solution. It's kind of long. You can do this like in 5 lines using substring, but we're avoiding substring and we're just using a elementary data structure. So yeah, I hope this made sense and I hope you enjoyed it. Thank you.